Hi guys, welcome to Interest Inc. So in the last video we have just discussed the basic idea and concept of trigonometry. So in the last video I have left you with some suspense, uh, that is, what are those ratios. So today I'm going to do both those ratios, but before that I want to tell you something about a triangle, and that is actually right angle triangle, because it's a main triangle in trigonometry. So this is 90 degrees, we know. So I'll write here 90 degrees, and this I'll take it as some theta. So if this angle is theta, then what about this angle? So I'll tell you that this is 90 degrees minus theta. How? Why? Because I'll tell you the proof now. So let's do it. So we know that if the sum of all angles, sum of all angles in a triangle is 180 degrees. Yeah, it's a very big rule. So by this I will prove the other angle will be definitely 90 minus theta. So I'll take this angle as alpha for now. This is alpha. I want to tell that this alpha, theta, alpha, this is gamma, alpha, theta, beta, these all are the Greek letters, because most of the scientists, mathematicians, all are from Greek, so they have just kept their letters to represent these variables. So yeah, so let's take this as alpha, or x also, we can take x or alpha, something. So yeah, I'll do now. So this is alpha. Yeah, so theta, I'll add theta to 90 degrees plus alpha, this should be 180 degrees. So now I'll add minus theta minus 90 degrees both the sides, minus theta minus 90 degrees both the sides, then I'll get just do it here. So here minus theta plus theta will be cancelled, minus 90 plus 90 will be cancelled, alpha will be there. So yeah, so alpha is equal to 180 minus 90 degrees, which is 90 degrees, and minus theta. So we have a proof that this other angle other than 90 and theta is 90 degrees minus theta. So we got an answer. Yeah, this was the topic I want to discuss. So now we'll go on to the ratios topic. Yeah, let's draw a right angle triangle for now. This is theta, we know, and this is 90 minus theta, and this is right angle, which is 90 degrees. So in the last video I have the possibility of 6 ratios for a triangle. So first I'll represent the lengths of this triangle. So x, y, z are the lengths of the triangle, lengths of the sides of the triangle. So now I'll write all the possible ratios of this triangle. So these are the ratios, the main ratios I'll get, and these are their reciprocals. Okay, these are reciprocals. Reciprocals means we'll just interchange the numerator and denominator of a p by q form, which is a rational number. Yeah, so now I've named them like jug, cat, dog, gauge, tack, and god. But the mathematicians who have worked so much on this trigonometry, they haven't named these ratios like some regular names. They have named these ratios with respect to the angle other than 90 degrees in a triangle, in a right angle triangle. So the angle other than right angle is theta and 90 minus theta. So based on these angles, they have named these ratios. So why these ratios? Why they have named these ratios? Why I'm answering this? Because they tried many things with triangle, rectangles, squares, all things. They have found a unique character in a triangle, which is mainly a right angle triangle, that they have found a unique value, a constant value for these ratios. We'll talk on that more in the next videos, but for now we'll just name these ratios. Yeah, so they have named these ratios with respect to this two remaining angles in the right angle triangle other than 90 degrees. So let's name how they named. Yeah, so I'll draw another triangle here. I can get more space by that. Yeah, so this is theta, this is 90 degrees, this is 90 minus theta. I am not writing 90 minus theta because uh, I'm just writing to respective to this angle. That's why I'm writing theta. That's it. So I'll name the sides x, y, and z. Yeah, these are the sides I've named. Yeah, respect to this theta, x is opposite side for theta. So let's write here opposite op. Okay, and z is adjacent side. Let's write adjacent. And we call the opposite side to 90 degrees as hypotenuse. So I'll write hype. So these are the important notions for a right angle triangle. So in respect to theta, so the first ratio I've taken is x by y. So this is like some opposite side by hypotenuse, opposite side to theta and by hypotenuse. So opposite side to theta is x and hypotenuse is y. So they have named this ratio as sine theta, or we can also write this as sine theta. This is the original one. They've just short it and they have written it as sine theta. They just removed one e, that's it. So we call this ratio opposite side to theta by hypotenuse as sine theta. And the next ratio I want to take is I just want to rub this. I'll give you the whole table at the last. Yeah, the next ratio I want to take is z by y. This is adjacent side to theta by hypotenuse. So they have named this ratio as cosine theta. Cosine theta. Just remember, adjacent side to theta by hypotenuse ratio, we'll call it as cosine theta. That's it. And we can also call it as, in short, we can also call it as cos theta. Yeah. So this is the second ratio, and the next ratio is x by z, which they have kept as tangent theta, and the ratio is opposite by adjacent. This ratio we call it as tangent theta, and also we can call it as tan theta. This tan theta is very familiar than tangent theta. So the full name of tan theta is tangent theta, and full name of cos theta is cosine theta. And yeah, The full names of sine theta is sine theta, which is samely pronounced. So yeah, let's move on to the next three possible ratios. What are those names? First, let me write these three here, and then I'll tell you about those three reciprocals of these three main ratios. So I've written the main ratios. Now I'll tell you about the reciprocals of these ratios. So first I'll tell you about the reciprocal of sine theta, which is y by x, and that we'll call it as first I'll write y by x, and which is hypotenuse by opposite side to theta. So we'll call this ratio, they have kept the name of this ratio as cosecant theta. Cosecant theta. Okay, so hypotenuse by opposite, which is reciprocal to sine theta, is cosecant theta, and we can also write it as cosec theta. That's it. Yeah, short form of cosecant theta. And the next is the reciprocal of cos theta. The reciprocal of cos theta is, I'll write it, z by y is cos theta, and y by z is reciprocal of cos theta, which is hypotenuse by adjacent side to theta. And we'll call this ratio as secant theta. And the short form of the secant theta is sec theta. That's it. Okay, yeah, so hypotenuse by adjacent side to theta is sec theta. And the next one, last ratio, which is reciprocal of tan theta, that is tan theta. Reciprocal of tan theta is z by x, which is adjacent side to theta by opposite side to theta. This we'll call it as cotangent theta, and the short form of this theta is cot theta. This is more familiar than cotangent theta. Yeah, so adjacent by opposite is cotangent theta. Now let me write all the ratios at a place. So these are the 6 possible ratios which mathematicians named. Okay, these 6 very important for trigonometry. Just the ratios, 6 ratios. We should be knowing these 6 ratios: just sine theta, cos theta, tan theta, cosecant theta, secant theta, and cot theta. These are the 6 ratios. And this is all for now. In the next video we'll be finding the constant values for these ratios with respect to theta. Theta can be any degree, means like any angle, 30 degrees, 120 degrees, 60 degrees, anything. For those we have a particular constant value. We'll be discussing on it in the next video, and we'll be discussing on laws and some formulas in trigonometry. Till then, bye. This is Jagadish.